Hello guys, in another tutorial. This time I will show how to create this automatic tank track geometry nodes. It's very handy when you, for example, want to have different shapes of tracks, and you don't want to lose time doing it in a regular way. If you're new to the channel, you probably are. I am Filip. I am a 3D animator, and just want to share my knowledge about Blender. It's a bit more advanced tutorial because that's something I've been missing on YouTube for a long time. Okay, so let me show the whole idea first and explain how it will work and how we will do that. So we will create a collection of cylinders. We can change their amount, size, and location. After that, we will scale them down on the y-axis. Use a convex hull to get the shape of the whole track, decimate that to get rid of this nasty geometry, and get a planar shape. Next, we will convert that into a curve, instantiate the track along the curve using geometry nodes, and add the gears. We will use some math to get this moving, and that's it. That's the whole idea. Now, let's get straight to Blender so I can show it in practice. Let's add a few cylinders and create more or less the shape I want. I'll maybe scale this one up and this one down. Now, let's put them in a separate collection. I will call it cylinders for now. Add a cube and go to the modifiers tab and create a new geometry nodes setup. I will bring the cylinders collection here by just dragging it from this tab, like that. Now, we will need a few nodes. Realize instances, scale elements, merge by distance and convex hull node. Take the instances and plug it here, scale it down, change this to a single axis, and select the x-axis and merge everything by distance. We will use the convex hull node. Now, let's add the decimate modifier and change it to planar. And we got rid of this extra geometry in the middle. I've already prepared the gear and the track model. Don't want to make this tutorial very long. Add a new geometry node setup. In this part, we will instantiate the tracks. But it's not that simple. We will need to use some vector math to get the proper result. So first, we need to create a custom array modifier to get the whole track. After that, we need to align the point's position to match the curve shape. How will we do that? We will capture the position of each point and separate it into x, y, and z. Curves have their own parameters, such as normal, tangent, and position. To make the track wide, we will multiply the normal of the curve by the x of each position.
So the normal is a vector pointing sideways. By multiplying it with a single value, we are just scaling the vector up or down. To align track to the curve, we need to sample the position of the curve somehow. We will use the sample curve node. It has a factor parameter. It's a value between 0 and 1. Imagine that the curve is made with an infinite amount of points. By having the factor set to 0.5, we'll get the position of the point in the middle. With 0, we get the first point, and with 1, the last point. So by just putting the y value of each point with a factor, we'll get a track aligned to the curve. But as our y values can exceed 1 or be less than 0, we can use module operation to look the values. Now we just need to add the width factor, and we have the track almost ready. Now the last step, the depth. But we only have the normal and the tangent. We need to somehow get a vector that is pointing up from the curves. If you look closely, there's actually something we can do about it. We can rotate the normal by 90 degrees on the tangent axis. After that, we can scale this new vector by the z value of each point, and we've just added the dash. Great. Now we just need to add all the vectors together, and we are ready to go. Now let's go straight to the Blender so I can show it in practice. First, let's create a custom array modifier I was talking about earlier. After that, we will handle the point alignment to the curve.
I set the multiply to 2 because my track length equals 2. You need to check your track length to make it work properly. Now let's group that so we have everything clean and organized. Now, the second part, creating the curve modifier. Add the capture attribute, position, separate XYZ, a sample curve, and a set position node. So, capture the position and separate the result into XYZ. Now, let's do the math we were talking about earlier. Let's take the normal of the curve and scale it by the X. Bring our track curve shape here and plug it into this socket. Add these together and plug the result into the position socket. As you see, it's kind of working, but the track is distorted, so something is not right with the Y value. Let's fix that. We need to multiply the Y value, but how much? The sample curve factor is a value between 0 and 1, and we have 20 tracks, and the length of each track is 2 meters. So, we need to divide 1 by the amount multiplied by the length of each track. And now it's fixed. Now let's add the depth. We need the vector rotate node and vector math. Take the normal of the curve and plug it into the vector. As this is the vector we want to rotate. Then plug the tangent into the axis socket, as this is the axis we want to rotate the vector around. Set the angle to 90 degrees. Take the result and scale it by the Z position of each point. Now, let's add everything together. Perfect. Can you see this hole? I don't like it either. That's because the factor of the sample curve node. We need to use the modulo operation to fix it. To make it move, we need to add the add node before the multiply node, like that. How to instantiate the gears. We will use the original cylinders, capture their scale, add new gears, scale them, and make them move by using some math. So the smaller the gear, the faster it will rotate. I think you get the point. Just follow the steps. There's only one last thing we need to do. Sometimes when we change the size or location of the cylinders, the curve gets reversed. To force it to keep one direction, we need to create a system that checks it. So take our curve, sample the curve point tangent, and check if it's equal, more or less, to a specific vector. If it doesn't, reverse the curve. Okay, and that's basically all. Now you can quickly create tank tracks. Hope you learned something, and if you liked the video, you can subscribe my channel and leave a like. By the way, all source files are in the description and in the pinned comment.
Okay, that's all. Have a good day, and bye.